Okay, we're gonna get started. So, good afternoon. Welcome back. Those of you who maybe tested this morning, I know that I think AP Calc was this morning. Some of you took that. There's some other stuff today too. Those of you who were testing, I hope your testing went well and that you're not too exhausted. And those of you who didn't and had their classes, I hope your classes went well. So first few things. Number one, those of you who are testing tomorrow, right? Our AP Stats exam is tomorrow. Starts at 1. Check-in for the exam starts at 12:30. All right. Make sure you're managing your time appropriately to start check-in at 12:30. Give yourself the max amount of time to get stuff ready. I still have a chunk of students in this class who have not completed the exam setup. All right, and not to necessarily call people out, but because it has to be done today, like there's no choices here, it has to be done. All right, we're gonna call people out, so I apologize. It's not what I like to do, but so it's necessary. All right, so if your name's on the list, you have not completed your exam setup. At least on my side, with the stuff that I can monitor, you have not done that. All right, if you're testing tomorrow, if this is not done by the end of the day today, you will not be able to test. It won't work. Now, 5th period does have the fewest number of students proportionally than all of my other classes who are not done with exam setup, so thank you for that. But again, it must be done, right? It is too late to cancel. The test is tomorrow. I think the last possible cancellation time was on like Monday. All right. So again, if your name's here, please complete the exam setup. You will not be able to access the exam tomorrow if this step is not done by tonight. If you have not completed any other AP exams, if you have not taken any other AP exams this semester, right, and you have not completed the practice exam or app demo, which forces you to go through a practice exam setup and a practice exam check-in, you will not have access to your exams, which means you cannot complete the exam setup. Right. Some students are having that issue where they'll go into the testing app and click to see their exams and it says that they don't have any. That is the reason why. You must complete the app demo or practice exam and go through the steps of actually doing check-in and setup before it gives you access to your AP exams. Right. So again, please complete these steps by tonight. The other thing I want you to consider, if you are just planning on not taking the exam, because maybe you got a fee waiver, it's not costing you any money out of pocket, you're just like, I don't want to take it, it's fine, it'll be cool. Please consider that the school still has to pay for the exam, which, you know, that's no money out of your pocket, no big deal to you. However, what that means is that future students who may want to take an AP exam and would normally qualify for a fee waiver will not possibly get that waiver because our school does not get as many because students are wasting them. Right, so consider the possibility that your actions today could affect future students and their ability to take an AP exam. Okay, so sprinkling a little bit of guilt there, but you know, I apologize. This is the reality of the situations. I'm trying to motivate you guys to just do this stuff. And again, even if you don't know if you'll pass the AP exam, give yourself a shot, take it. If you pass, you get college credit. If you don't, you still pass this course, hopefully, right? And that still looks good on your transcript. So there's that. That's all we're going to say about that. The other thing is grades. Most of you in here are seniors, meaning your classes are done on Friday. Right? That means this is the last class for AP Stats. This is it, last one. All right, I do not see you guys on Thursday or Friday. We do not have live sessions those days. Okay, I have to finalize grades for this course by the end of the school day on Friday. okay? If your grade is not what you want it to be, or if you're not passing this course, you need to do stuff between now and Friday. The best thing I would recommend to do is the multiple choice assessments. You could theoretically complete all 6 of them if you have done none of them all semester in about an hour if you just guess. As long as you get more than 0 points, your grade will improve. Because right now they're all in the gradebook as zeros if you have not done them. Okay, so without studying, without looking at any notes or anything at all, you could simply guess, right, through the 6 multiple choice assessments that are assigned and possibly pass the course. Right, that means there's really no reason to fail the course. Please give yourself a shot, give yourself a fighting chance, just try to do some of them. You don't even have to do all of them. Do half of them and see if that gets you up to a passing grade. Okay. I'm grading things as they come in. The multiple choice assessments grade themselves. As soon as you're done, the grade updates. Okay. I'm constantly grading things throughout the days here. Anything that's been submitted today, I've already graded. All right. Your grade in Canvas is the most accurate grade that you have right now. Please check that out. Especially if you've turned things in this week. That's going to be more accurate than Synergy. Are there any questions about grades? All right. So then what we're going to do here today is a little bit of last minute review and practice. Nothing quite as intense as what we've gone over the last couple weeks with the free response questions. We're going to do a Kahoot. It's basically just a review of some vocabulary and concepts that we should know. So we'll get this running. Where did I put that? There it is. Right, please, I do encourage you to join this Kahoot even if you're not taking the AP exam. Because it's good review. I want that there. We'll go there. Go there. All right, so the Kahoot game pin and everything should be up here on the shared screen. Hopefully I did all that correctly. And please join the Kahoot. It consists of 20 questions. They're all multiple choice. Give us an opportunity to review some stuff. Well, we are going to get started. If you have not yet joined the Kahoot, you'll be able to find the game pen at the bottom of the screen once this thing gets going. If a distribution has data mostly on the left with a few points spread far to the right, it is fill in the blank. And the correct answer is that it is skewed to the right and the mean is greater than the median. All right. So remember, the direction of the skew is the direction the tail of the distribution is pointing. If I have a majority of the data to the left and a few points down to the right, that's going to have a tail to the right, so it is skewed to the right. The mean will always move closer to the tail. Right? It moves away from the median in the direction of the tail. Since the larger we have the points far to the right, that's in the positive direction, the mean will be greater than the median. Right, and so that is why it is not the green or square option. Going, Carrie jumps out to the early lead. Which of the following numbers is not part of the empirical rule? The empirical rule is the fancy name for something that has to do with our standard normal curve and the proportion under the curve within 1, 2, and 3 standard deviations of the mean. Right, and 90 is the one that does not belong. Right, the empirical rule is also known as the 68, 95, 99, 7 rule. 68% of our distribution is between 1 standard deviation of the mean, 95% is within 2 standard deviations, and 99.7% approximately is within 3 standard deviations. 90% does not come into play. And Carrie's holding on to that lead. We got a bunch of people moving on up. Which type of plot best determines whether or not a linear model is appropriate? Think about what we talked about in chapter 3, the most recent chapter. And the correct answer is a residual plot. Right, the normal probability plot tells us whether or not a distribution is approximately normal. It does not have to do with whether or not a linear model is appropriate. Right, a box plot uses the 5-number summary to essentially graph quantitative data. Right. It's otherwise known as a box and whisker plot. The stem and leaf plot is another way of displaying the distribution of quantitative data, where we list the stem down the middle, and then we have the leaves are the numbers that go along with each stem. Right. I know that's a really bad explanation, but it's hard to say that without a picture. The residual plot, right, tells us essentially how far away each point in a scatter plot is from the linear model based on the linear regression. The residual plot looks like a basic graph with a horizontal line running through the middle of it, and then points on either side of that horizontal line corresponding with points in the scatter plot, but it only displays how far above or below that line the points are. If that residual plot does not show a distinct pattern, and there's points that aren't grossly far away from everything else, then the linear model is appropriate. And Lali moves into the lead. All right, which of the following is an example of qualitative data that is different than quantitative? Qualitative. All right, and the correct answer here is zip code. All right, the other three options are all quantitative data. Height, income, and wingspan are all things that you could find the average of, makes them quantitative. Qualitative data, akin to categorical data, is a way that you can categorize things, or it is a quality something can have. All right. It does not make sense to calculate the average of zip codes. It doesn't tell us anything, number one, but it just doesn't make sense. Even though it's a number, it is qualitative and not quantitative. Right. And Cass moves on up to second place. Which of the following is resistant? And when we say resistant, we mean resistant to outliers. The correct answer, both things in the correct answer will be resistant. If one of them is, then the whole thing is not. Right, and the median and IQR is the correct answer. Both of those are resistant to outliers. It is the measure of center and measure of spread that we can use most commonly when describing a skewed distribution. It can be used for any type of distribution and is resistant to extreme values or outliers. The mean and standard deviation are not. If you have one really far out there outlier, that will drastically change your mean and standard deviation. Right? Mean and range are also affected, and median is not affected, but the range is. And so the correct answer is median and IQR. That is why we typically want to use the median and IQR when describing skewed distributions, because they are more reliable and resistant to extreme values. All right. We got Sitlali holding the lead. Jackie and Daniel moving up to second and third. Which of the following is part of the 5-number summary? One of these is part of the 5-number summary. The other 3 are not. Which one is? The median is the only one that is part of the 5-number summary. The mean, mode, and range are not. Right? The mean is an average. We do use that quite often, but it is not part of the 5-number summary. The mode is the number or value that occurs most often, which doesn't really come into play that much in statistics. We don't use the mode very often. And the range is just the difference between the minimum and the maximum, which we can find with the 5-number summary, but it is not part of the 5-number summary. All right, we got Daniel and Cass are in second and third, so Lali's holding that lead. What is the formula for finding a residual? How can we determine how far away a point is from its linear regression model? From the line for the linear regression? All right, and this one is observed minus expected. All right, remember, in a scatter plot, once we have the linear regression, that line that models that scatter plot, the line represents the expected value, right, of the response variable for each given value of the explanatory variable. Otherwise, for each x value, the line corresponds to the expected y value. The residual represents how far away each point in the scatter plot is from that expected value, which is how we get the value of a residual is observed, what we actually, the data we collected minus the expected value we would think we should get based on the linear model. Right. Daniel moves into the lead. Brian's moving on up 3 spots. Right, which of the following is not a condition for a geometric distribution? There are 4 conditions here. Which one is not needed for a geometric distribution? Consider what a geometric distribution helps you determine. All right, the one that doesn't belong is the fixed number of trials. Right, a geometric distribution essentially describes the expected number of trials needed before getting the first success. So it helps us calculate or determine the number of trials necessary, which means we can't know that ahead of time. That's what we're trying to determine. All right. The other 3 are all necessary. The 4 of these together are necessary for a binomial distribution, and where we're trying to determine the probability of attaining a certain number of successes within a certain number of fixed trials. That's binomial. Geometric, we have 2 possible outcomes, succeed or fail. Right, the probability of success is the same for each trial, and every trial is independent. Those 3 things must occur for a geometric distribution. We're finding the number of trials. And we have no movement at the top. A researcher plans to obtain a random sample of heads of households from each of 23 counties. What kind of sampling is this? Right, this is a stratified sample. Right, it's not just a simple random sample because we're not just randomly sampling from the entire population. Right, the key is that this says, where's my mouse? From each. Researcher plans to obtain a random sample of heads of household from each of 23 counties, meaning the 23 counties are the strata. We've already broken everything down into its strata. We have 23 of them. From each of those strata, we're going to obtain a random sample. All right. It's not a cluster sample, because remember, in cluster sampling, we break everything down into its clusters, and then we randomly select which cluster becomes part of the sample. Everyone within a cluster must be part of the sample. You do not sample from within a cluster. Right, so we could randomly select 5 out of the 23 counties to be in the study, and then everyone in those counties participates. That would be a cluster sample. A systematic sample, which nobody chose, is not something we really did in this course. It didn't come up because it's not the best way of sampling. Systematic sampling would be like, I'm going to have every third person take part in this study. It's a systematic way of selecting people. And Lolly and Daniel swap places there, and Lolly's back on the #1 spot. All right, which of the following is not important in the design of a good experiment? Which one is not important? All right, so that first option there, replicate the experiment many times, is not important in the design of a good experiment, mainly because of the wording. Right? This says replicate the experiment many times, meaning the experiment has already been designed. We're repeating it. I can't possibly have to account for this within the design for the design to be good. Okay, so this one has a little bit of wordplay going on in it. The other 3 things are all absolutely necessary when designing a good experiment. You need to have a sufficient number of subjects. A good experiment doesn't contain just 2 people. All right. When we talk about replication in study design, that's meaning we have enough people. All right. Randomization, we need random assignment to get usable results. Right? That's part of being able to perform a proper inference, is that we randomly assigned treatments. All right. And control of confounding variables. That's the control that we must have when designing a study. How can we control the other things that might affect my results? The better I can control those confounding variables, the more likely it becomes that I can say that one thing is causing another thing. Brian moves into the top 5. Which of the following is a parameter? Remember, parameter has to do with population. Statistic has to do with sample. All right, sigma is notation, right? That's the kind of looks like an O with a tail at the top of it. That's our sigma. Sigma represents the population standard deviation. So sigma is a parameter. Right? P hat is a sample proportion. Right? Same as X bar is a sample mean. Right? And B is essentially the slope for a linear regression model based on a sample or scatter plot. Okay, so in this case, sigma is a parameter. The others are all statistics because they have to do with samples. All right, we got Daniel moving back up to the top spot. Looks like Mai moved into the top 5, and Esme is making a charge up 4 spots. Which of the following is a statistic? This kind of goes along with the last problem. Which one is a variable used with sample data? All right, and this one is the standard error of B, which is also the standard deviation for a sample. All right. So another thing to consider, or another thing to try to remember, Greek letters are typically used as parameters, having to do with population things. Normal letters, or things with a accent over the top of them, like the hat or the overline, have to do with samples. All right, so beta, right, the Greek letter for B, beta, is the slope for the linear regression model for a population. Mu is the population mean, and sigma is the population standard deviation. And Jackie moves into the top 5. If all other information for a confidence interval is the same except for the confidence level, which is true? All right, so this one, 90% confidence interval is narrower than a 95% confidence interval. All right, if all the other information is the same, except for the confidence level, what's true? So consider, if I'm 100% confident that the mean is between 2 points, the only way to be 100% confidence is if I have covered all possibilities. Then I can guarantee that that's going to be what it is. So that's going to be a very wide interval. As my confidence level decreases, right, 95%, 90%, and so on, right, the width of that interval gets smaller, right, because the possible values get closer together, which means I'm less confident that that will contain what the actual parameter is. Right, so a 90% confidence interval is narrower than 95% for the same set of data. Taylor moves back into the top 5. Stephanie's moved up 4 spots. Which of the following is the conditions check for normality for proportions? I apologize for the typo. Remember, this is asking about proportions, not means. Pretty even split. The correct choice was choice B and C. Right, the first option here, n is greater than 30, the large sample size, has to do with means. Right, the condition, the large/normal condition for performing a confidence interval or significance test for means is that our sample size is at least 30. The other two there, NP greater than 10 and N1 minus P is greater than 10, is testing that there are at least 10 successes and 10 failures right, within my sample. That's the condition for proportions. That is our large counts condition. All right, and Brian moves up to number 3. Daniel holds the lead. What is the formula for the lower cutoff for an outlier as defined by modified box plots? How can we determine the lower bound of a possible outlier using the box plots, otherwise known as a 5-number summary? The correct answer is Q1 minus 1.5 times the interquartile range, or IQR. Right. That is how we find the lower bound. Q3 plus 1.5 IQR is how we find the upper bound, the upper cutoff for an outlier. The other 2 options are not anything that we use. They're just to throw you off. All right, so if you multiply 1.5 times the interquartile range, which is Q3 minus Q1, right, and then subtract that from Q1 and add it to Q3, you get the lower and upper bound. Anything outside those numbers would be considered a possible outlier. And the top 3 stay the same. Cass and Mai move on up. The power of the test would be greatest for which sample size n and significance level alpha? Remember, the power of a test is the probability that your significance test will correctly find evidence for the alternative hypothesis when the alternative hypothesis is true. Yes, n equals 30 and alpha equals 0.05 is correct. To increase the power of a test, you should increase the sample size or increase the significance level, or both. In this question, the one option with the highest sample size provided and it is accompanied with the highest significance level is n equals 30 and alpha equals 0.05. That would result in the highest power, or the greatest power. And we stay essentially the same. In a 4x3 two-way table, the number of degrees of freedom is, so when performing a chi-square test for homogeneity or independence, how do we determine the degrees of freedom from our two-way table? All right, and the answer is 6. Right, degrees of freedom on a two-way table, which we need when calculating a significance test, chi-square significance test, is the number of columns minus 1 times the number of rows minus 1 in that two-way table. And this is always excluding rows and columns for totals. Those don't count. So in a 4x3 two-way table, we have 4 minus 1 times 3 minus 1, which is 3 times 2, which is equal to 6. All right, if you did 4 times 3 and got 12, you're doing too much. Degrees of freedom are too high. All right, Joanna moves into the top 5. Given non-empty events A and B, what does it mean when events A and B are mutually exclusive? Yes, events A and B do not have any common outcomes. When that is the case, these events are mutually exclusive, meaning if one event happens, I know the other one did not. They are disjoint or mutually exclusive. They have nothing in common. And Leslie moves into the top 5 with a streak of 3 correct answers. Which is the correct interpretation of a normal probability plot? Excellent. Approximately linear, so approximately normal. When you create a normal probability plot based on a distribution, if you get a line or something close to a line, that is evidence that the distribution is approximately normal. And Joanna moves back into top 5. Last question, what test would you use to see if there is a relationship between GPA and SAT score? All right, so if you didn't get this one right, and that's probably not your fault because this has to do with chapter 12. Right, we did not learn how to do linear regression t-tests. That's what chapter 12 covered, was tests using linear regression. So the chi-square test for independence would allow us to check for an association between GPA and SAT score, but not test for causation. Right? When we're looking for a relationship, we're saying that one has an effect on the other. Association does not necessarily prove causation. Right? The linear regression t-test allows us to check for significance, which allows us to say if there is some degree of causation or relationship between the two. Pardon me. All right. So if you got that one wrong, I apologize. That was not your fault. Where'd my mouse go? And that was the last question. Third place we have Cass. Second is Silali. And Daniel is first place. Thank you all so much for playing. All right. So that was the extent of the review for today. The AP exam is tomorrow. For those of you taking it, I wish you all the best of luck. I hope that you feel prepared. Hopefully. So this is the last class. I want to thank you all very much for your participation this year and your perseverance. This year has been difficult for many reasons. It is not the school year that we were all hoping for or anticipated having. The overall lack of live in-person classes and ability to do that was very difficult. I know many of you had things going on outside of your own control that made this school year very difficult, and I want to commend you on being very persistent in coming to class and doing the best you could. In particular, this year is not going to be a fair reflection of who you are as a student and as a person, and and your capabilities. So I want you to keep that in mind and see this year as what it was, as a moment in time. It is not a summation of what things actually, like what it really was, right? So hopefully things continue to get better, things turn around, things start getting more positive. I hope you all have success in whatever it is you choose to do after high school. Many of you are graduating this year. I won't have the opportunity to really see many of you again. So I just wish you the best. I hope that whether you're going to college, whether you're going to a four-year college, a Palomar, going to get a job, helping support your family, whatever it is that you have coming up next for yourself, that you have success with it, that it's fun for you, that you find something that's fun for you, and that your life treats you well. I mean, I don't know, I just wish you all the best. It's kind of bittersweet. A lot of you guys I didn't actually get to know very well, but I hope you all the best. Those of you testing tomorrow, good luck. I hope it goes well. That's about it. I don't know what else really to say about it. It's been a pleasure teaching this class with you and having y'all participate. Some of you, hopefully I'll see in the future, and we'll have a good laugh about how horrible this school year was. All right, take care and be good to yourselves. Don't be too hard on yourselves. And have a great rest of the week, a great weekend, and an awesome summer break.